Howdy folks, welcome back to another video. Today is January 1, 2026. First video of this year. We're going to work on my 4-jaw chuck for the lathe, which is out of balance for some reason. It has been from day one, and even with a part dead centered indicated in, it'll shake like a son of a gun, which I'm going to show you here in a minute. But this, of course, is an independent jaw chuck, as opposed to a scroll chuck like the 3-jaw, 6 jaws. You can get a self-centering 4-jaw chuck. You can get all sorts of chucks as far as configurations go. And this is also a D1-4 Camlock, which is really typical for lathes of this size. And how these things work, which I'll show you when I pull the other chuck off the 3-jaw and put this one on. You probably already know this because if you watch machining videos, this is like all over YouTube. But these pins lock in with little cams that turn in with your chuck key on the spindle nose and pull it in. The way these things are supposed to work is this is a taper of a certain degree. I don't know what it is. This face here has a relationship with this taper. Essentially, when you pull this chuck on via these pins and the cam, it's supposed to pull in on the taper and kind of lock the taper in before it hits this face. That's why you have to kind of tap these things a little bit, or you should have to, to get them off to break that taper. And then the things will come right out. I have a suspicion, I'll tell you right up front what I think the problem with this is, because I have indicated the outside of this chuck, and when it's in place it's dead nuts. But I think that's got casting abnormalities as far as how it was cast, all the rough casting inside of it. I have gloves on here because it's cold out. It's like 40-something degrees. If you look at these webs, if you will, these areas here, definitely some differences between one versus the other 3. So this one is pretty even. This one's pretty even as far as the casting goes. So is this one. This one down here is not. Oh, sucker's heavy. Right down in here is a big lump. And I think this is probably where it's out of balance. Usually you have a 0. This looks like a C, but I think it's a 0, which is a master jaw. And it corresponds with this one up here. And you line this up to the 0, or what the appropriate mark is, on the spindle nose. And that's supposed to be a position where this thing is in proper alignment. I don't know what they mean by that, what the manufacturer, might mean by alignment, but this thing, in my opinion, should be balanced out when it's lined up with the 0, and its fitment is appropriate and shouldn't have all this vibration. You can get a really kind of good shot here, which I think is the problem. Right in there, you see that lump. This thing just wasn't fettled properly, if at all. And that shit's also usually hard as a freaking coffin nail. So ultimately what I want to do is machine out whatever is the part that's making this out of balance. It is really hard to use when you go anything higher than about 600 RPM. Even about 600, it shakes the crap out of the lathe. So let's go over to the lathe. We'll go ahead and take the 3-jaw off. Oh, by the way, these Camlock guys here, if you weren't aware of this, these probably M6s because it takes a 5mm hex to take these out. These are locking screws that all these really do here is keep these from turning. They're supposed to be loose like that. And what you can do is you can take these locking screws out and turn these in or out to get the proper pull in on this taper. That's already been done. I've already done that a long time ago. So this thing locks up against the spindle nose, no problem. I got this board I always keep here for this purpose. Protect the ways, in case the thing gets away from you. And up on the top here, here's your 0 point, your master jaw location, 0, 0. For this 3-jaw self-centering scroll chuck. You'd expect this thing to run pretty true, which it does, and balance-wise the same, but it's also a solid chuck on the back side. It doesn't have those webs. To get this thing off is pretty simple. We release the cam locks on the back. There's a mark you line them up to tighten them, as far as lock them in, and there's a mark you line them up to for loosening them or taking them off, which is essentially just 90 degrees. It's not pulled in right now by any mechanical force, so you think it would fall off, but that's because, again, it's pulled up to the spindle nose. This is the beauty of one of these things. So you gotta watch your hands in here. and just give her a tappy tap. It breaks it loose from the spindle nose taper, then you can take it right off. Now, as you can see on the back of this one, totally different construction. Probably why it's not out of balance. You know, as I get older, I can see why Adam Booth uses one of those little crane dealios he puts on his lathe and on work tables and stuff. I forgot the name of the manufacturer, but I tell you what, these things get heavy. He's got a bigger lathe though on that Precision Matthews, and of course his American Pacemaker. Well, that lathe's a lot bigger. So you definitely would have to use some sort of I think he uses his gantry crane for that one, but anyway. Every now and then I stone the taper here. Stone, dude. Make sure there's no burrs on it, but it's okay for this. Here's our 0. I also noticed that this one doesn't exactly line up to 0, but it's pretty close, you know, as far as the forejaw goes. Ugh! You're gonna watch this because, you know, you don't want to ding that. Oh boy. Carefully. There we go. Yeah, it doesn't exactly line up, but we get it as close as we can. That 0 is here, and the one on the spindle nose is here, so it's probably, geez, 35, 40 degrees difference. I have tried this clocked around at different locations. In other words, put the 0, clock it around 2 different ways. I tried both of those ways, those combinations, I should say, and that hasn't made any difference. It's something in the chuck itself, and like I said, I'm pretty sure has to do with that casting. Let's take the jaws out. All right, so like I said, these are independent jaws. So it doesn't have a scroll in the center. It just has these screws, and you can move the jaw in and out. Or I should say the threads. They haven't been deburred ever. But anyway, you got the big screws in here. That turns. And so you wouldn't need in other words, you wouldn't need an inside and outside jaw if you needed to put these in the other way around. All you do is just turn them around. As opposed to the 3 jaw that you have 2 sets. I'm set for pounds and ounces. 1 pound and 2.0 ounces. I suspect these are going to be pretty much exactly the same. I wouldn't expect these to be off. It's not that, it's not these, but you know, you got to rule it out. 1 pound, 1.9 ounces. So 0.1 of an ounce difference. The other reason why I want to take these out is to show you with no jaws in it at all that this thing will still vibrate like a son of a gun, which isolates it to the chuck itself. Taking them out and weighing them in, and we'll spin it. Then we're just going to put the jaws back in, and we're going to indicate some bar stock up. I think I'll show you what I'm going to use. Well, I'm sorry, 1 pound, 1.8 ounces, so it's 0.2 ounces difference. I don't think that should make hill of beans worth of difference. I mean, if it was spinning at 10,000 RPM, maybe. And that's even lighter. 1 pound, 1.7 ounces, which is interesting. Huh. So that's the lightest. 1 pound, 1.8, 1 pound, 2.0, and 1 pound, 1.7. So we've got 0.3 ounces difference, the worst case scenario on these things. That's the 1.8, so there is a 1.7 in there, 0.17. You know, I don't know if that's going to make any difference on this, but like I said, right now we'll just move stuff out of the way. We'll spin this up and I'll show you what I mean as far as the vibration goes. So we'll run her, I'm going to put her at 360 to start. I'm going to engage the safety squints just in case. You never know what this thing's going to throw. Contact. So there's, you know, no problem. I've run this at this speed before. Here we go, 600. And there we go, he starts shaking. I know this is really hard to see. I come up with better visual aids later. Now we'll go to 800. That's the next step up on the gearbox as well. Not quite as bad. There's a problem in this gear head too, because at 800 RPM, If you hear this, I don't know if it'll do it again. No. Sometimes it goes bang after it comes up to RPM. Almost like one of the gears and the head is moving. I popped the top off, but the lid, I can't see anything wrong. Yeah, like that. All right, let's go to 1,000, which is the next step again. This is as high as I'm prepared to go. It's not that bad, but it is still shaking. So when it spools up, spools down at the higher RPMs, or if we simply run it at 600, this is where it's got the worst shake. Either way, any speed should not be doing this. So how are we going to determine where it's heavy as far as trying to figure out how to balance this? Well, I'm glad you asked that question, because I will show you how right now. I got to do a little measuring first here, and I'll show you. I need to know the width of this chuck from the very back, which of course is the same as where it faces up into the spindle nose, to the tip of the jaws, which is about, it doesn't have to be exact, it's about, let's say, 4.5 inches. I've got this set evenly. You know, you can pick up these lines. That's what these lines are for. So you can kind of get them set approximately. You watch Adam Booth's channel, he explains all this a lot better than I can. Because we're going to run a piece of 1 3/8 bar, solid bar. It's cold rolled, so it's fairly round, right down the guts of this. It's 26 inches long. So we need to kind of know that to figure out something here. It will fit down the spindle, down the guts. We know it's 26 inches long. What's 26 divided by 2? So 20 divided by 2, of course, is 10, and 6 is 3, so 13 inches. And half of 4.5 is 2 1/4. We're going to split the difference and put the center of this point between here and the top, the edge of the jaws, on the center of that bar. 13, and we minus 2 1/4, and we measure it in from the end, and then we're all good to go. 10.750, which of course is 10 3/4. I could do this in my head, I know that, but I'm just giving you a visual representation of that. You don't know that, but I'm fooling you to think that I can do it in my head. You know, so I just took, you know, half the bar and just backed out half the chuck. 10 3/4 right there. So that's good. Okay. I'll just put a mark here, you know, just because, in case I move it. Close enough. So right now, half of this is sticking out from here equally to the other half on the inside. We can kind of look at that. If we look down the guts, you can see it's right there. So yeah, it's right about there. So it's like about right there. So you can see it's about even. So close enough, right? And now we just have to indicate it in, which, you know, ain't gonna be too hard. I am just going to bring these up evenly, looking at those lines. Not too bad. Pretty simple process. Tighten your highs, loosen your lows. About 2 thou. I want it like dead nuts. All right, that's perfect. Now, is it square in and out? I don't know. We really should check that. It will make a little bit of a difference, but not much. That's pretty good there for what we want to do. If you haven't already figured it out, you probably, I'm sure you have, because we're going to lay this across some sort of a balancing rig. And if you watch my videos, you probably know exactly the one we're going to use. Yeah, that's definitely close enough. So we verify that this thing is concentric with the chuck, and it's not cattywampus in the chuck, because when we indicate here and here, it's nice and straight. Now, could it be bent on the inside, you know, because just that side of the bar goes down or up or is twisted? Sure. But chances are, if it's straight out here over a length of about 8 or 10 inches, it's going to be straight inside there too. So there you go. Now, if you guess we're going to use a Black Widow tire balancing stand, you're right. I'm going to get this whole thing out, the bar and everything in the chuck, just by undoing the cam locks and hopefully not killing myself. Wish me luck. See if I can do this. There it goes. I'm sure this is going to have some weight to it, but not too bad. All right. Ah, yes. Here we go. You want to do some curls while we're at it? Oh, I can't do that. I'm too old. Whew, I got to take a breath. But I leveled the stand. I cleaned the bearings and lubricated them up with some of that slick stuff. You can see that this sucker's definitely got a big time heavy spot. Because that bar is, we have to assume that bar is running true on both sides. It's running true on one, it's going to be running true on the other. Let's get this a little better centered. Let's see exactly where it's heavy. Sir Barks-a-Lot is going at it. Let me get some light on the subject. Okay, so this is the heavy point down here. Where is that spot that I pointed out before? Is it in there? I don't think it is. Now it might be over here. Yeah, there it is. Haha, look at this. Okay, so let me back out here a little bit and show you that that is the low spot right here. We'll mark this. But look right what's inside there. That big lump of shit in that casting. Well, yeah, there is a lump of stuff there, but take a look to the right side of that pin. You see how much fatter the web of that casting is. This is something I just failed to realize at this time. But later on, it plays a ginormous role in the final solution to get this thing balanced. So stick around and you'll see what I mean. So that is definitely participatory to the weight distribution issue we have here. We really don't know how much. And even machining that out of there, how are we going to determine how much material we've machined out? Do we weigh it? So there's going to be a little T&A, trial and error going on as far as trying to fix this, but no question that is a heavy spot. I was kind of hoping it would be more like this, you know, indicating that one particular area. But, you know, it could be on both sides of this web too. If it's thick on that side, it may be thick on the right side too, you know. Probably just what we're going to have to do is just cut both sides in the milling machine, which is not going to be hard at all with this, as far as setup goes. As far as the idea of doing it this way, I had this idea all along to do it this way, but I hadn't really committed to it until I watched a video from Mark's channel down in Vienna, Rotary SMP, link in the description. A short time ago, he put a video out on balancing grinding wheels for a surface grinder. That's where I got the idea that kind of validates this though. So I said, I'm going to do it. I'm going to try to figure out with you right now though how much it's out of balance. Try to use some wheel weights, I guess, and tape them on there temporarily. See if we can get an idea how many ounces it's off, something like that. We'll give it a shot. Okay, so the bottom's the heavy side, obviously. So the top side must be the what? Light side. So I've got 10 quarter-ounce weights up here right now, taped in. And that's really close. That would be close enough right there, I'm sure. You have to account for some variances probably in the setup. I would say that it'd probably work with that amount of weight either added to the light side, which I don't know any way I can really do that, or we take off that much weight on the heavy side. That seems to be the most logical way to do it. How we determine that, I don't know. I got a couple of ideas, but yeah, the problem is we have to do the setup all over again to verify it. So it would be nicer if we could just add the weight to the light side here, call it a day, but I just don't know I don't know any way we can really do that. So we are going to machine off the stuff that we don't need, and hopefully it will work. Let's go this side and see what happens. Yeah, she tries to come up, but I think that it'll probably be okay. 10 quarter ounces, whatever that totals out, I don't know. Well, that's pretty stupid, but that would be 0.25 or 2.5 ounces rather. Jesus. 0.25 is a quarter ounce times 10 is what? 2.5. Takes a rocket scientist to figure this crap out around here. I swear to God, I need more coffee. Okay, so how am I gonna figure this out? I have a plan. I always have a plan. Sometimes it's a plan that sucks. What we're gonna do is we're gonna take this thing and set it up in the mill. We'll clamp it with just a couple of clamps from the T-slots, and then we'll put a 3/4 inch high-speed steel. I have a pretty long 4-fluted one. That's what I heard, at least. It was pretty long. And then we're gonna machine that out. So each one of these, I don't know what you want to call them. What did I call them before? Let's put some light on it. These pockets are even as far, the webs, that's what I call them, webs. I'm going to measure them roughly with a caliper, just a regular spring type caliper. We simply go in there and hog that crap out as far as we can to make it the same or as close to the other three as possible. And I bet you that is going to solve this. I think we'll be able to get this thing close enough for, so it doesn't shake the bejesus out of us. I had some lunch and I changed my mind, leaving the vise on. Why not? I don't want to retram it. It fits this chuck almost the complete maximum opening here, but I could always take off a jaw, and so it fits there. So that's number 2. Number 3, this sumbitch is heavy. I nearly busted a nut the last time I took it off the mill table. I want to leave it on. I don't want to bust another nut. We got 2 straps up here, nice and tight. It ain't going nowhere. We'll leave these pins in, the studs. Not going to be a problem. The pocket of interest is right here. We're going to do this part first. We'll get the width done over here. So you can barely get this down over here, but over here you can go all the way down. So it's fat on this back side here. Over here it's not. It's about the same as that, about the same as that. So it's heavy in here, and it's really heavy in here, as we could see before. We're going to concentrate on that first. I hope the high-speed steel works. I don't have a carbide cutter that I can do this with. I'm not really a big fan of this anchor lube shit. I really am not. But in this case, on cast iron, this stuff works pretty good on this stuff when you're machining this, especially with tapping it. It's about the only thing I've really found it to be good. I think we'll go ahead and try that. All right, so I changed my mind again. I'm using this 3/4 inch roughing end mill. It's a used one, but I'd rather have used this one than my nice 4-flute. And this should do the job. I've got clearance around the cutter now, but I don't want to hit the actual bottom. I'm just going to go down to my 0 and back off some. Lock the quill and see what happens. I wish you could see a little bit better, but unfortunately, until I start coming up, you're not going to be able to see too much. .630 RPM. See what happens. Trouble is I can't see either. We may have to plunge this, and that's what we'll try. I'm gonna get my flashlight. Oh yeah, it's cutting. Oh yeah, she's most definitely cutting that. I'm going to manipulate the X and the Y here. See if we can bring this around and bring it in. Sure don't like it. It's definitely cutting it though. I just wish I could show you, but I can't right now. Anyway, you get the idea. I'm just going to have to shut you guys off and try to work on this and try to just dig this out best I can. All right, I wish I could have gotten you in there for some more action, but unfortunately I couldn't, and we are done. I'm not taking any more off. So that's the heavy side. You can get an idea looking straight down at it what the amount of material that came off was. That's pretty good considering, and when you use the calipers, I wish I could find them. There they are. I can't find anything. Like pick up roughly toward the bottom. It's pretty much the same, maybe even a little bit more, but averaged out, like it's tight there, tighter there. This whole section here was thick. It was thick boy. And so we took that way down. Now, is it too much? Doubtful. I would guess if anything, it's not enough. I don't know if that equals 2.5 ounces of material. See how we did. This start, I'm gonna pop her down to 360 again and start where it wasn't vibrating earlier. See if it does now. That might be something to try before we go to the 600 and then higher. Let's try that. So 360. Well, that's nice. But it was before. 600 RPM. Here we go. And it's still shaking. I don't think it's quite as bad, but it is still shaking. It's still heavy. 800. I'd say it's a wee bit better, especially when you're at a higher RPM and it spools down past that harmonic location. But it needs more. It needs either that or some sort of counterweighting, which may be the next step, because I don't have a whole lot of more material to take out of there. All right, so this is what we're going to do. We know that this is probably still heavy. I say probably because by rights we should put it back on the balancer to make sure, because what would happen if we took too much off and now this is heavy? I seriously doubt that. That was 2.5 ounces out. What we're going to end up doing here is I'm going to put 2 holes. Not in this center pin. This pin is, I believe, pressed in. It's got like a little fork on it. It holds the threaded stud that adjusts the jaw on this particular spot. So it keeps it in, it's a thrust mechanism. It keeps it from going out or keeps it from going in. And so I'm not going to mess with that, because I'm going to put a hole here and a hole here. And I'm going to drill and tap it for M6. So we're going to stack weights up after I drill holes in them, and we're going to dial this weight in right on the lathe by adding weights or subtracting or cutting them in half. I don't know. We're going to figure something out, but we're going to dial this sucker in no matter what, because again, I believe this is heavy. We need to make this heavier. We need to balance this thing out. Should work. Good enough. See if this works. Slow that down and go a little bit more. Probably should finish this out by hand. I think I will. Okay, you get the picture. I'll bring you back when we're done. All right, I got 4 1/4-ounce weights. They're smaller than the ones that I mocked this up with. I forgot I had those, just some old junk ones in my parts drawer. And of course they have a 6mm hole drilled in the center of them, so they're a little less than 1/4 ounce, but we have to account for the weight of the bolt too. So I'm going to kind of round it off and say there's a 1/2 ounce on each of those for a total of 1 ounce. And so we'll see what it does. Remember, this is the heavy side that we cut, and this is the light side, which is now heavier. Okay, here we go. Just a little bit. Let's go to 8. Let's go to, what did I say? 600. Let's go to 800. Now that's pretty smooth right there at 800. Go back to 6. Let me turn the power off for safety. I'm going to add 1 more to one of these. That is 1 more added to the mix. 600. Contact. No, it's not 600. Ah. Still a little bit. I'm gonna go to 1,000 for the heck of it. That's nice. As it ramps down or spools down past that 600 point though, it definitely gives us vibration. So I'm gonna add one more to the other one for a total of 6. This is what an unmolested one weighs. 0.25, so they are 1/4 ounce. And the one with the hole in it, 0.21. All right, 6 weights on each, 2 bolts, 600 RPM. Man, it's still there. It is still there, but it's better. I'll add one more and that's it. Wow, it's still a little bit off. That's just amazing how out of balance this this chuck is. Gee whiz. Especially after taking all the material off over there. I just don't think we can do anything else. Better than it was, a lot better. Okay, so here's the final configuration. Change the weights around. Instead of using those kind of lead zinc ones, I have those spoke weights in my parts drawer as well. The total weight of those, after I had to put an M6 end mill down them to fit those bolts, is exactly the same as what the number of weights I had on there was. I think it was 8. When I multiplied it out, it's 1.26 ounces. And after I drilled, we actually used an end mill to open those up. They're slotted, but they have a counter bore at this end of it. So that counter bore kind of wouldn't let it slide off the side, nor does it over these bolts. So I just run a M6 down them. These are Loctited in place. The 2 of these are 1.27 ounces, so they're the same. And it does the same thing. I mean, it's the same weight, so you would expect it to be behaving the same way, which it is. But you know, it's a hell of a lot better than it was, and that looks a hell of a lot better too. And I was really concerned about these weights here. You know, they squeeze, you know, they'll smush, and even with Loctite, they're going to loosen up. So this way I can get a good purchase on those bolts with Loctite blue, and I did the grub screws up that come with them, why not? And so that's the way she's going to stay. So it's the best I can do. I would say, like I said before, a success, but I was hoping for a little bit better result, but unfortunately, that's the best we got. Take a guess at who you think that glass right there belongs to. I wish I had thought of this before. I think a glass of water in a clear cup like this is a perfect representation. Let's go up to 800 for the hell of it. A little bit less. Pretty much nada. Unfortunately, there's some sort of harmonic that this spinning mass creates at 600 RPM that I just can't seem to get out. Okay, I don't like this. We can do better. Okay, before I pull the weights that I put on yesterday out, you can see it's still heavy down there where it was. Yeah, she's definitely heavy. And that's why it's still vibrating out. So I just did a Google search for balancing a 4-jaw chuck. I don't know if you've ever heard of the channel Haxby Shed. He's over in the UK. I subscribed to his channel, and I found one of his older videos, about 5 years old, where he was balancing about the same size, diameter-wise, 4-jaw chuck for his lathe. So what he ended up doing was he figured out the amount of weight it was out of balance, just like we did with the weights, and then calculated how much to drill out on the heavy side, which would be here, okay, on this particular chuck, around the rim. Came up with essentially was his chuck needed to be lightened up on the heavy spot by 12 grams. I'm not going to go through all his calculations because he's kind of come up with a standard for us, because he figured out that if you put about 3.5 holes that are 5mm diameter, a certain depth, which calculated into imperial about 1/2 inch, the 3 of them at 1/2 inch and then 1 at 1/4 inch depth, that relieved 12 grams of material, cast iron, from the heavy side. So I'm going to get these out, we'll reweigh this, and we'll make some conversions and use his calculations as a guide, because it was successful. And then figure out how many holes we need to punch in on this side. We'll go around with like a 5mm end mill, put it back in the milling machine, just move it around and make the appropriate amount. Okay, let's remark this location as the heavy spot. This is with the weights out. Man, it is just wicked heavy. Yeah, it seems to be, it's not in the center of this web right here. It is more over to this side of it, as you can see. It's more like over here, not over here. So we'll use that as a guide and punch some holes around that. Okay, here's 7 1/4 ounce weights. Besides the tape wanting to come off, that's pretty damn close. Okay, let's do one more. Yeah, that's it right there. 8 1/4 ounce weights. We had 10 on it earlier, so we've only shaved off a 1/2 ounce with the machining we did on the other side. Well, here's what happened. I'm thinking about it like a tire. Taking weight off the other side of a tire, which you can't do unless you modify the rim. We add weights to the other side opposite the heavy. We're going to need to drill a bunch of holes. We'll use his calculation. I think he listed how much per hole he figured at a certain depth of the material that he took out weight-wise. Take the appropriate amount of material out, and I think we should be pretty good at that point, because we are way, way heavy still, as you can see. All right, let me give you a briefing as to where we're at. This may get a little complicated, so just pay attention because there's a quiz afterwards. This is a still picture from that Haxby Shed video where he's calculating out how much material to take off of his chuck. Now he figured out, using a 5mm drill bit, how many holes to put and how deep they should go on the back of his chuck at the heaviest point to get 12.1 grams out of it. That's all he was off, was 12.1 grams. He came up with 3 holes, that's 5mm holes, 2.6 centimeters deep, which is I think around an inch, and then 1 at 1 centimeter deep, and that equals the 12.1 grams. He used this formula based on the density of cast iron. I don't really understand all this too well. He's a smarter guy than I am, but I'm using his numbers as a guideline. The 12.1 grams, and at a 5mm depth, or I should say diameter of a drill bit or an end mill or something. And when I did the calculations out, let me bring you back over to the chuck. I figured that because we had 8 1/4 inch weights on here, 8 of them, and that's 0.25 ounces each. When you do the calculations on that into grams, that's 56 grams. That's a hell of a lot more of material than 12.1 or 12 grams. Well, if I was using a 5mm end mill or a drill bit, I wanted to do like 5 holes. How deep would they have to be? They'd have to be over 3 inches deep. This thing is only 3 inches deep, so I said that ain't gonna work. And I took a look at these webs. You notice the distance between that center pin and the outside here? And in this one here, where the 0 is, it's about the same. But over here on this fat one, it wasn't. And I say it wasn't past tense. and hogging the crap out of that side, which was fat. This was the fat side of it. It's not the side that we did before that had all that excess casting material in there. That distance between the pin and this edge, you can see it isn't touched. It was correct, but this side was really fat. It was way off. I captured the chips with a magnet and I weighed them. My objective was to get close to 55 grams. So the first time I had like, what, 36 or something like that. And then the second time after going down to that next step, I ended up with 55. So that's 55 grams hogged out, where the heaviest part was right there. But now the heaviest part has moved, because I put this back in the chuck, obviously, on the lathe, and I re-indicated in our, excuse me, I got gas, our bar stock again, and we are heavier, but over to the side a little bit now, but not as much. You know, it's not as bad. So now what we're going to do is put some weights on it and see how many ounces, which we'll convert into grams, and then see if we can put it onto the mill and punch a certain amount of holes based on Haxby Shed's formula there, and take the rest of this out and get it dialed in exactly. We'll put 3 weights up here and see what it does. It wants to go there, but I think 4 would probably be too much. We could try it. The resolution of this, if you will, if you want to use, I think will be appropriate term, of this test rig is not finite enough, I think, to discriminate between 3 and 4 weights, but we could try it. Start at the top. Let's move our way down here. Well, 4 might be it. We cut it in half. Isn't that amazing? All the material I pulled out, 55 grams worth, and we've cut that in half. All right, so keep one thing in mind. I did not have the foresight earlier in the initial machining to capture and measure the material that we removed. But the material we did measure is 55 grams worth. We started at 8 weights. Now we're at 4 weights. So you can kind of figure out about how much the total amount of material that's going to need to come out of here is going to be based on that. Because we had 8 weights before. Let me do some calculations and figure out if we can do this with the whole method or not. Or is this too much weight and we've got to hog out some more down here or not? I don't know. I am still heavy by 4 weights or 1 ounce in total, which is 28 grams. Too much still to drill a series of holes like right here where I put these marks. They would have to be like 1.5 inches deep, and there'd have to be like 7 or 8 of them, something like that. Put it back in the mill and take 28 grams more of chips out of material. And then once I do that, we'll put it back on here and I think we'll be good. I mean, if I was off like 1/4 ounce or something like that, then yeah, I'd probably just drill some holes, or even 1/2 ounce. This one is just ridiculous. So 28 more grams of material. I'll do that off camera. All right, it doesn't make much sense to put the jaws in and indicate the bar stock in, because we may not need to do that. The numbers say that this is right, so why not just use the glass here? 600 RPM right now. Contact. Oh yeah. I don't even feel that. That doesn't even vibrate any more than it normally would with even a 3 jaw. I mean, there's going to be a little vibration. Who knows about the gears and stuff inside? That's a lot better than before. I mean, that's almost perfect. Yeah, we got a little bit, but that's really good. Let's go to 800. Make sure it's still okay there. Absolutely. A lot better. Let's go to 1,000. Go to 360. And again, 600. I mean, there is a slight amount of vibration. You can see it in the cup. but it's so minuscule. I don't even know if it's worth chasing that. All right, we're gonna run this up to speed with a workpiece in it, or at least this bar stock. See what it feels like. You know, like if you were gonna use it for real. All right, that's close enough. All right, we are locked and loaded. Where's my glass? Here it is, or my cup. Let that settle down. And yeah, have a drink on me. That is really smooth now. Barely moving. Feels real good. You gotta believe me, when I first used this thing and up to this point, the faster you put this thing up to a point, like 600-800 RPM, it was really bad. When you ran it a little faster, it did smooth out because I guess the harmonic was different, but that's my range that I would be using this chuck in, really. 600-800 was virtually unusable. That's even better. Absolutely nothing wrong with that. Okay, so after spinning it up in the chuck, as you saw yesterday, this is a new day. Same setup, same bar, didn't touch anything. So this 1 3/8", which is like 35 mil solid bar stock, cold rolled, pretty damn good, but the resolution is only gonna be what it is because of limitations. This sucker is in freaking balance, especially compared to what we had. I mean, it just wanted to drop like a stone down to that heavy point. Now, speaking of heavy point, this was stupid of me not to see how much thicker this area was. But what was throwing me off was, in the initial setup, you know, the way it was in the bar or whatever, this was shown as the heavy spot, which is why there's a mark there. So this was the first heavy spot right here. All right, that's first, and this was the second heavy spot here. This one only showed up after we started taking some material out of there. And again, it could be because the way it was put on the bar. There are still variables in here, but we got it as close as we could. Well, once I realized that this just simply needed to be taken out, instead of adding weight to the other side, it ain't a tire for crying out loud, or a wheel. So that was pretty dumb because it was so fat over here compared to these guys, how much offset this was. So yeah, I'm real pleased with this. And I just wanted to show you, you know, kind of give you some closure to this as far as how this resolution plays out onto the balance stand itself with this setup. Well, I got a hell of a mess to clean up here. I think I'll do it tomorrow. I don't feel like doing it today. And I'll make it short and sweet. My initial idea was dumb. I'm glad I slept on it and thought about it and said, maybe I ought to look online and see if somebody else has done this already. Thanks a lot to Haxby Shed. He's got a really good channel and I've been subscribed to him for quite a while. In case you're wondering, I don't have the original chips that I took out in those first operations earlier in this video. Let me show you what the total was I took out just hogging out that section when I put both of those piles together. 85 grams, can you believe it? Well, which is basically what we calculated, you know, that makes sense. You can kind of figure out about how much the total amount of material that's going to need to come out of here is going to be based on that. So let's go ahead and estimate the total amount of weight that we took off this thing, even though we didn't measure the initial material taken off in the original machining ops. First of all, we put 10 weights on in total. After that initial machining and ditching those counterweights, we were down to 8 weights. And then at that point, we took out 55 grams, and then we were down to 4 weights. And then we calculated we needed to take out a 28 gram amount more to get down to 0. So if we started with 10 weights and we went to 8 weights, that's the area we didn't measure. All we have to do, since we know 8 weights went to 4 at 55 grams, is simply divide 55 grams in half. That's roughly about 27 grams. So 55 plus 28 plus 27 And the reason why this works, as far as collecting the chips, is because everything went into the little recesses between the webs. So it's really easy to pick up with a magnet. And seeing that it's not razor sharp chips like from steel or something, get a little dirty in your hand, but you can pick them right off the magnet and get a pretty accurate representation on a scale like that. 85, 86 grams. Man, that's huge. The aggregate would be all the chips we took out in the first operation, getting all that crap out of there before. Yeah, it could be, I don't know, it could be 100. So this chuck just was way out of manufacturing specifications, I would assume. Either that or it's just a piece of shit, one of the two. I was thinking of scrapping this. Now I'm going to keep it and use it. So as always, thanks for watching. Don't just repair, restore. Catch you on next video.